welcome to AG Online Tutorials. We started a series on volumetric analysis and we've been able to cover the theoretical aspect of volumetric analysis. So today we'll be looking at standard WAEC questions as regards to volumetric analysis. That's the first question you always find in your practical chemistry. So we'll be starting with June 2013 was past question. So the question now is Burette readings initial and final. Let me just quickly run through them. Must be given to 2 decimal places. Volume of pipette used must also be recorded. Now if you read through, let me just jump to A is a solution containing 0.05 mole per dm cube H2SO4. B is a solution containing 1.4 gram per 250 cm cube XOH. So we're given the equation of the reaction as follows: H2SO4 plus 2XOH gives the product X2SO4 plus 2H2O. Okay, now the question we asked here now is we should, from our results gotten above, we should calculate the concentration of B. We should also calculate the molar mass of XOH and the relative atomic mass of X. So without wasting much time, we'll go straight to what we want to do. Now, we've gotten our average titer value from our practical work already to be 24.85. Now, our major aim is to aid students know what to do after getting their titer value. Most students can carry out practical work easily, but when it comes to the calculation aspect, they become confused and don't know what to do. So that's the major aim of carrying out these videos. I'll also send list of formulas. You will love to go through them. If you're interested in knowing more about the theoretical aspect, you could join our group and the link is down below this video. So let's start. The first is concentration of B in mole per dm cube. Now, the first thing I advise students is to get their data set. Your concentration of acid should be written down units correctly. Concentration of base is what we are looking for. Your volume of acid, we've calculated that through the practical we did to be 24.85 cm cube. Volume of base is also 25 cm cube. Number of acid 1, number of base 2. Now, some people are confused on this number of acid. You can indicate it from your equation of reaction. The equation of reaction, the acid here is 1, while the base here is 2. So let's dive into it. Now, some people ask, how do I know the right formulas to use? Now, if your Ca is given and your Cb is not given, you use cover majorly to get the concentration of the base. But when your Cb is given and your Ca is not given, you do the same thing. But when the both are not given, you find alternative means to get one so you can use your cover to proceed. Now, we can use our cover in this question. Substituting correctly, Ca times Vb, which is 24.85, Cb is what we are looking for, times 25 is equal to 1 over 2. So our number of acid is 1, number of base is 2. So if you do it correctly, you get 0.094 mole per dm cube. That will be our concentration of the base. Now the second question now is the molar mass of XOH. Now take note of this formula. You will love to write them down. Take your pen and your book, write them down. Mass concentration is equal to molar concentration times molar mass, right? Now what's your mass concentration? Look at the name, mass concentration. That's mass over volume. Your molar mass, mole over volume. So let's proceed. Now we have our mass from the question given to us to be 1.4 and our volume is 250 cm cube. Now don't forget to convert your cm cube to dm cube, right? So we doing that, we have 1.4 over 0.25. That's after being converted, you give us 5.6 gram per dm cube. Okay, let's proceed. So we've gotten our mass concentration to be 5.6 gram per dm cube. What are we looking for? Molar conc, right? We are looking for our molar concentration. Now, rather we are looking for our molar mass, not molar conc, sorry. We are looking for our molar mass. So our mass conc is 5.6, molar conc is 0.094 because we've calculated for molar conc already in the previous question to be 0.0994. So we proceed with that. Making molar mass subject formula, you get your molar mass to be 56.34 gram per mole. Now, how do we now get the relative atomic mass of S? Now, we've been talking about molar mass is the sum of individual constituent elements of a compound. When you add up their molar mass, you add up their individual masses together, you get the total molar mass of that compound. But in this case, it's different because we don't know what X is. So what we do is we have our X plus oxygen, which is 16, then hydrogen, which is 1, gives us the total molar mass, which we've calculated earlier on, to be 56.34 gram per mole. Now, X plus 17 equal to 56.34. If you make X the subject formula, you note that X will be 39.34. Now, this depends on to how many decimal place you are working. You may get 39.5 and so on. So this is the solution to 2013 June was past question.